All right, folks, section 9.7, solving quadratic functions using square roots. So just to review, you learned the first way, which was graphing. And then yesterday we talked about factoring. And next we are going to learn about square roots. Square roots actually aren't super difficult, but I want to show the whole screen here because I want to ask you guys, what do you notice in these, or what do you notice is missing that you usually see, well, oftentimes in a quadratic equation? Keeping in mind, you know, the standard form. Y equals ax squared plus bx plus c. What's missing? This guy. We are not finding the x term in there. And that's why we can solve these with a little simpler method. Remember, it's the fact that you have the x squared and the x that causes solving to be more complicated. When you have just the x squared or just the x, it's pretty straightforward. So it's just the undoing of it again. So when we see an x to the second, we have to unpack it, right? We have to go backwards. So the opposite of squaring something is square rooting. So you will square root both sides. But because it's squared here, when you take the square root, there are two options. So your options are plus or minus 13, because if you were to substitute a 13 here, 13 squared is this, and negative 13 squared would be 169. Okay? So, and if you go ahead and try this, what are your thoughts? Hopefully your thoughts are no way Jose, because the square root cancels there. But we cannot take the square root of a negative number in the real world, okay? The real numbers world. You have to enter the imaginary numbers world to get that. So in the imaginary numbers world, it's 7i. Because the square root of a negative 1, I'm saying this for those of you, I know there's a few of you out there that are just dying to know this stuff. Square root of a negative 1 is I. Okay. So therefore I squared is equal to 1. Anywho, we won't go there. So if you didn't get that, it's okay. Just a thought for those out there that want to delve into that a little bit. So there's no real solution for this. Okay? Whenever you have an x squared equaling a negative, no go. Can't do it. So let's keep that in mind as we go forward. Solve this. Again, you draw your line. It's the solving is the same though. You have to get this alone first. You have to get the x squared alone. So subtract 7. Thank you, Bertie. And then we need to do square root of both sides, which is still 0. Draw your line. What are we going to do first? That's right, you got to isolate the x squared, just like you'd isolate an x. So move to 49. And again, even though it happens to work out here because that's a perfect square, you get in the habit of getting it isolated. But I am leaving it that way. Those of you that want to grab the calculator and divide that out, you're making your life way more difficult, because when I do a square root here, square root and square root, because you can square root that whole thing, you're going to get plus or minus 7/4 and be done. because the square root of 49 is 7, square root of 16 is 4. And don't forget there's two options, the plus or the minus, positive or the negative. So these we don't need to. Now when they do say round, then you're going to need to use your calculator. So you're going to find the square root button on there. It's a little different with each calculator. Help each other out. A lot of you have similar calculators to each other, so find someone with the same calculator. Make sure you know how to use it. And you're going to square root that, and it is going to be plus or minus. I'm going to take mine out. So those of you that have the same one as this, it's right there. Okay, so we're going to push 15 and we're going to do square root. And there's the answer. It says nearest hundredth. So remember that's tenths, that's hundredths. And now you have to look at the one after the hundredths to determine, does it stay the same or go up? So what would the 7 stay the same or go up? Same. Good. So 3.87. Okay, before I can do that on here, I need to solve. Subtract 90. Right away you might be thinking, oh, it's negative, can't do it. No, you can't make that judgment until you're at the very end, because watch what's going to happen now. I divide by a -3 and now it's positive again. Okay, so don't see a negative and automatically think it's no real numbers. Square root both sides. I'm going to move over here. X equals, find 30, push the square root button, tenths, hundredths. That's a 7. Does that kick that up to an 8? It sure does. So 5.48 plus or minus. And lastly, our applied problem. Ms. Perzada is building a retaining wall along one of the long sides of her rectangular garden. Pick out those little pieces here. Right away, I'm going to draw a rectangular garden. Retaining wall along one side. Okay, so just one side. One of the long sides, so I knew it was that one. What does it tell us about this garden? The garden is twice as long as it is wide. Okay. So what do you, if we label this is twice as long, so pick a letter for that. You can pick width, it doesn't matter, or X. Then that means that's 2 of those. It also has an area of 578 square feet. 578 square feet. What will be the length of the retaining wall? Okay, so area of a rectangle is length times width. That is equal to the area. So it's a solving problem. What's 2w times w? 2w squared equals 578. Solve. Divide by 2. W squared equals 289. We're going to square root both sides. W equals plus or minus 17. But can we have a width that's a negative 17? No. So we're going to stick with just the 17 yards. I think it was yards. Or is it feet? Feet. There. So that's my width, 17 feet. What will be the length of her retaining wall? Oh my.
Sorry.
It's okay. 2 times 17 equals 34 feet. That's how long her retaining wall is. So there we are. Feel free to rewind it if you need to hear another problem again. All right. Take care.